Okay, so I'm gonna sit here, because if I stand there, you can see my forehead, and that's about it. Hi everyone, how's everyone doing? Good? Having fun? Yeah? Okay, so I'm going to be talking to you today about me and Docker and our rocky relationship. So a little bit about me. I'm a fourth-year student in computer science right here in Waterloo. I'm in the co-op program, so I've had a couple of internships so far. And those have been primarily in infrastructure, site reliability engineering, that kind of thing. And in that period of time, I've gotten well acquainted with this thing called Docker. So here on this slide, we have a picture of me in my natural habitat, which is obviously being uncomfortable inside an open concept office. And we have the Docker logo, which is a whale, and it's got some containers on it. It's very cute. It's a very cute whale. Oh, sorry. Well, can I go back? No, I can't. Huh. Maybe if I go down here. I don't know what that is. Okay, sorry. So down at the bottom is my website and my Twitter handle. You can totally tweet at me. That's cool. You can take pictures of me and tweet them at me. I love seeing myself. But also on my website, if you go to fbox.ch/speaking are the slides. If you want to follow along, there's some code if you want to like copy paste it or something. I don't know. Okay, so I don't know why that's there. Okay, so if you don't know, Docker is this very popular technology that exists right now. And what people use it for, and I'm going to get kicked out of the secret Site Reliability Engineering Club to say this, but it's putting lots of smaller computers inside a computer. So if you had a Linux host running somewhere in the cloud, or you just had a server, you could use Docker to make lots of smaller Linux computers inside that computer. So let's say you had a host that was running like Ubuntu 16.04, you could create a bunch of Docker containers, which is the name for these things, and they could be running anything. They could be Arch, they could be Red Hat, they could be CentOS, and those, they would be running their own operating system, they would have their own processes, they would have their own networking ports, all that kind of stuff. And this is used in production to deploy services. So you might have heard of microservices, or that lots of monolithic apps are moving to microservices, and a lot of the time this is implemented by making lots of Docker containers inside of servers. And it's really great for that because it allows you to have different services running in the same host that might have dependency clashes. So maybe you have one service that needs this one specific version of a package, and you have another service that needs another specific version of a package. Before, you would have to spin up virtual machines or spin up a couple of different hosts so that those dependencies wouldn't clash. With Docker containers, you can do it all in one host. It's really great. So one important thing to know about Docker is that the containers each have their own set of ports. So if you normally serve web on port 80, it would be serving web on port 80 in the Docker container, but that would be mapped to some sort of ephemeral port in your host, like 3443 or something like that. And that's also true of processes. So if you have a process ID, the process ID for that process inside the Docker container is not what the process ID of that process is in the host. Okay. So at the last co-op that I was working at, which is where that picture was taken, I was presented with a problem that they wanted me to solve. And that problem was basically that we needed to find the process ID of a process running inside a Docker container, given the port that that process was serving on. But the port was the port that it was running on in the host machine, and we wanted the process ID of it also in the host machine. The reason they wanted this was that the MySQL database administrators would run show process list inside of a MySQL instance, and they would see all these processes that were trying to connect to their database, and what show process list gives you is the host IP address as well as the port number that that process is serving on in that host. So they wanted to be able to backtrack what service inside of our infrastructure was trying to make this connection to the database. So they were like, can you write us a script that will do this and will work with all of the microservices that are deployed in Docker containers? So I tried this, and I tried to use netstat because that's what I know and that's what I use. But netstat was not installed inside the Docker container, so that was a problem for me. And also, running netstat on the host wouldn't actually show me processes that were running inside Docker containers. So I had to come up with a script that would work anyway because they needed it. So a couple of caveats before I get into the solutions that I looked at. This had to work on Ubuntu's 10, 14, and 16, and only those operating systems, as that's what the infrastructure that I was working on had. I was the SRE, so I was not the dev of these Docker containers. I had no look into the Docker file. I didn't know what was installed. I couldn't change the image or anything like that. And I'm going to be talking a lot about netstat, and I like netstat. I've been using it for a long time, and it just happens to be what I use, but that doesn't mean that this talk is only about netstat or that it's the best tool or I think it's the only tool you can use. So the first solution that I found after some heavy Googling was this tool called LXC netstat, which, if you don't know, stands for Linux Container Netstat. Docker is kind of based off of Linux containers, but it seemed like LXC netstat was a tool that was going to work and was going to show me exactly the information I wanted. So I tried it out, and it worked. I just had to find the container ID of the Docker container, which I did with this docker inspect command. And once I had that ID, all I had to do was run LXC netstat and pass it the flags for netstat that I wanted, and it seemed like everything was working fine. Turns out, though, I was running this on my dev box, which was an Ubuntu 10.04 box, because I guess interns are only good for Lucid and nothing better. So when I tried to run this on the actual production servers, it didn't work because most of those servers were not running Lucid. So I didn't like LXC netstat, didn't solve my problem. Went around on Google a little bit more, Stack Overflow, the regular stuff. Found this tool called ncenter. So I was like, okay, my dev box, not good. Can't do that. Lucid isn't what we want. So let me use this other dev box because I have root on all the machines, because that's what you get when you're an SRE. So I went onto someone else's dev box, and I tried ncenter. And this time, all it needed was the process ID of the container. So I used the docker inspect tool again to find that PID. And then I just ran ncenter, and I passed the command that I wanted to pass, which was netstat-plnt. Again, you see I got that PID, 5341, running on Python. Everything was hunky-dory. Turns out that dev box is Xenial. So this was only going to work on Xenial and later, so that tool, not great either. And then I was like, maybe I can if Xenial, then this tool, if Lucid, then this tool. Turns out neither of those tools are on Trusty, so had to find something else, right? So then, more Googling, lots of Googling. This was like an entire week of my internship. I was just on Google. I found this thing, and it was like IPnet NS exec. I was like, I know what IP is. IP show link. I can list all the interfaces. I had no idea what this tool did, but I found a blog post, copy-pasted some code, and it worked. And I was like, yeah, I'll find the PID of this container. I had to do that for ncenter, sure. Sure, I'll make a symlink and a directory. That sounds fine. And then I did it, it worked out. I got the PID of that process that I was looking for, and everything was good. So I just, happy time. It worked everywhere. It worked on Lucid, Trusty, Xenial. Those were the only boxes I cared about. And I put it up for code review. I wrote the whole bash script. I added comments and everything. And then someone was like, why? What are you doing? What is this directory, and why are you creating a symlink? And this is my mentor, so I couldn't just be like, oh, hey, someone just help me pass this code review through, right? You have to do what they say. So I went back, and I actually read the blog post, and I learned something interesting about namespaces, which is that I didn't really understand them at all beforehand. And so what I learned was that a Docker container is kind of just a set of isolated namespaces. Linux namespaces are what control the network. So there's a network namespace, right? And that controls the list of interfaces that a host has, the routing table that the host uses. That's all in the network namespace of the host. There's a process namespace, and that has all of the process IDs of all the processes running on the host. A Docker container has an isolated set of these namespaces. So the Docker container has its own network namespaces and has its own network namespace and its own process namespace. And the way that Docker works inside the host is that it has its own network namespace, and it has this virtual Ethernet, which if you just think of a real-life Ethernet cable, it's just a virtual version of that between itself and this Docker bridge on the host. And that's how it talks to the networking on the host. So what I didn't understand when I was Googling all of these things and just copy-pasting all this code was that what the problem I was trying to solve was, how do I run netstat with the network namespace of my container, but with the process namespace of my host, which is, and so this is just, if you had, just to illustrate the way that that diagram works, if you ran IP-link show on a machine that had 2 Docker containers spun up, you would see the Docker 0 bridge, and you would see both of the virtual Ethernets for both of those containers that were up and running. Yes, so I needed to actually be looking for this information about how do I run a netstat with the network namespace of the Docker container and the process namespace of the host, right? So the first thing that I learned was all of the problems that I was coming up with and why I was getting all this unexpected output was because I didn't understand the namespaces correctly. What I was pronouncing as ncenter was actually ns-enter. So I was like, oh, I'm a namespace, enter, Docker network namespace. I got it. It makes sense now, right? And ipnet nsexec is super great because you can execute any commands inside of a network namespace that you care about. So if you have all of these containers running and you want to run netstat or elseof or ifconfig, you can do all of those with ipnet nsexec. So now this code makes a lot more sense. I'm like, okay, I got the PID of the container, right? Okay, this is the directory where the network namespace is associated with a specific process live. And then I just need to make a symlink from that network namespace where it's stored to somewhere where ipnet ns can actually read it. And I have to give it a name that makes sense that I can type into my terminal. Got it. That makes sense now. So in conclusion, oh gosh, I can't read backwards anymore. Okay, yeah, sometimes you're not looking for the right words when you're looking for a problem. The phrase that I kept Googling and kept getting stuck on was run netstat inside Docker. And like, this wasn't coming up with anything useful for me, and all these other people were also looking for that question and not getting the right answer right. But what I really needed to understand when I was looking that up was like, how does a network namespace work inside a Docker container? And how can I execute a specific program or function in that namespace? And actually, when I started looking up with like the phrase namespace, I was getting all of these results that made a lot of sense. My job is mostly Googling. Site reliability engineering is a lot of Googling, like for tools that work or like problems that people have already solved. Seems like most of the problems have already been solved. You just have to find someone else who already solved it. And it is okay to be wrong, and it's not okay to post a code review with code you don't understand. You will get called out for that. But it is okay to post a code review with code that is wrong, and people will correct you, and people will help you find out what you did wrong. These are some sources. So that Platform 9 blog post is one of the ones I mentioned. It talks very specifically about namespaces and ipnet ns, so if you want to read that. The next one is just generally about Linux network namespaces, and the last one is a Stack Overflow question about ncenter or nsenter. These slides are available on my website, like I said, fbox.ca/speaking. I won't be around for most of the unconference and also basically none of tomorrow. So if you have questions, you can hit me up on Twitter or you can go to my website. I've got like other contact links there. And that's all. Thanks for listening.